Good evening, everyone. We now begin the first technical session of day 5 of the 6-day ATAL-sponsored online faculty development program on advancements in cloud and edge computing, research and industry perspectives, organized by the Department of Computer Science and Engineering, Adi Shankara Institute of Engineering and Technology. The first session of the day focuses on a highly relevant and interdisciplinary topic, which is IoT and machine learning, which explores the convergence of intelligent data analytics with connected devices to enable smart systems and real-time decision making. It is my privilege to introduce our first resource person for the day, Dr. Ajay Kumar, Professor and Head of the Department of Electronics and Communication Engineering at Adi Shankara Institute of Engineering and Technology, Kaladi, Kerala. Sir brings with him rich academic experience and strong expertise in emerging technologies. His insights into IoT and machine learning will provide valuable perspectives for both research and practical implementations. Sir, we are honored to have you with us today. I kindly invite you to take over the session and share your expertise on IoT and machine learning. Thank you. Over to you, sir.
Okay. I'd like to add one more point. Dr. Ajay Kumar is also heading AI and IoT Research Lab at Adi Shankara, which is about 3 crore funded by MIT. Just for information to all participants gathered here.
Thank you, ma'am. Thank you for your introduction. So I will share my PPT.
Okay.
Okay, is it visible?
Yes, sir. The PPT is visible.
Is it moving now?
Yes, sir.
Okay. So, yeah, good evening all. So thank you for this brief introduction. So before I start this session, I would like to thank Dr. Ramani Bhai, who gave this opportunity to interact with you all. So as this topic of our FDP is advancements in cloud and edge computing, research and industry perspectives. So I would like to have an interaction with this particular topic called as smart environmental monitoring frameworks using IoT and machine learning practical implementations. So this is the topic which I will be covering today. So myself, Dr. Ajay, as introduced, Professor in Electronics and Communication Engineering Department. So this will be the outline of today's session. So as I said, when ma'am invited me for this particular FDP, she told the topic will be IoT and ML. And I thought we are hearing this term for last few years, this IoT and ML. I thought all will be having that basic understanding of what is IoT and ML. And I thought how I should go ahead with particular this about this session. I thought I will share my research experience. So my research experience is through my lab. So I will explain in detail. So basically I will covering IoT, machine learning, and I will explain 2 case studies. First case study will be air quality monitoring system. So in that I will cover both IoT and ML aspects. And the second is regarding a flood prediction system, which is done by AWS and also river level forecasting and prediction. And here also I will share the IoT works and also ML works. So in between, if you have any query or doubt, you please interrupt me, no issue in that. So I am open to solve or open to share whatever I know. So as I said, I have a lab called a Center for AI/IoT Innovation, which is in our institute. So it is fully funded by Ministry of Electronics and Information Technology, Government of India, for a project. So this project is undergoing now. So it's 2.5 years old. So still 6 months to be completed. So the main vision is to develop intelligent IoT solutions to solve environmental issues. So we have basically 4 to 5 objectives. So in that 2 objectives I will be covering today. So these are the objectives, as I told. One is to have a system which monitors the air quality. The other is to predict the flood, which is quite alarming thing in our area, which is Kaladi. And then another is to distribute water, smart water level distribution, and also to develop an startup ecosystem in our campus. So these are the different objectives in the project, which is funded by Ministry of Electronics and Information Technology. So I will start with the basics of IoT, as I said. So I think all of you might be knowing what is IoT. IoT is nothing but Internet of Things. Here nowadays we call it as Internet of Everything or anything. So the things here, it may be any physical device, any living or non-living. So any things we can actually interconnect by using internet and sensors. So the basic element which is needed for an IoT network is actually sensor. So nowadays we have almost all sensors in all the fields. So actually research in sensor development is actually a hugely or a highly researched area. And nowadays we are concentrating on indigenously developing the sensors without depending on the other countries. So that is actually a hot topic, sensor development. So sensor is basically the element which is needed to actually develop an IoT network. And based on the application, we can choose our sensors. And another important thing which is needed in an IoT network is connectivity. So we need a stable and fast internet connection, so that the sensed data is actually transmitted or communicated with the end nodes. So what we call it as in IoT, as I told, we will be having physical things or living or non-living things. So we will be trying to connect those things by using a sensor. So what we call it as a smart object. So a smart object is the IoT device which we are actually concentrating here. So that particular smart object will be having sensor, it will be having a processing unit, it will be having a memory, and also it will be having a communication device. So basic idea here is to collect the data intended based on the application by using sensor. If needed, it can be processed in that particular smart object itself. And actuation. Actuation is the action which has to be done based on the data collected. So that can be done then and there itself, or otherwise you can use that data, you can analyze that data, you can process that data, you can store that data. All these things are possible either in the edge or in the cloud. So those things are based on the applications. So basically what we call it as a smart object. So smart object is actually a basic ingredient in any IoT network. So as I told, we'll be having smart objects, and next is to have a gateway. So a gateway is for the, so to route this data. To route this data, if you are using a cloud, we have to send this data to cloud for further processing, analyzing, and for further enhancement of the data. And at the end, if you are going to display it, you can use a display. Or if you are pushing that to a website, you can do that. Or if you are pushing that to a mobile app, that also can be done. So all these things are done in next stage. So once all these things are done, so the basic thing is you can integrate cloud. So integrating cloud means you have to apply some of these algorithms for analyzing the data. So based on the application, you can go for any type of analytics which is needed. So that is the beauty of IoT. IoT is actually an enabling technology for AI, an enabling technology for blockchain, an enabling technology for terahertz communication, for 6G, 5G. So it's actually a technology which can be synced with any of the developed or newly developed technologies. So that's why we concentrate. Nowadays, we are concentrating on integrating AI with IoT. So IoT generally means Internet of Things. So if you are actually using AI with IoT, we call it as IIoT, Intelligent Internet of Things application, or IIoT applications. So this is intelligent Internet of Things, that is intelligent IoT. So intelligent IoT, so roughly or barely, if you are actually receiving the data or raw data, and you are doing nothing, or you just displaying that particular data, means there is no use. So that's why if you having a data, you need to use that data for a meaningful application. So for that, this AI will help us. So AI-driven adaptive and predictive IoT systems are quite common nowadays. So how it will be intelligent? So integration of IoT with intelligent decision-making capabilities based on AI, ML, and data analytics. So these are actually the enabling technologies which will help IoT to make the solutions intelligent. So that is one of the goal of our lab, to use this machine learning, this deep learning, and also AI algorithms to make it so to generate intelligent IoT solutions. So that is our goal actually. And IoT data is actually enriched with the AI and data science techniques to enhance this decision making, automation, forecasting, prediction. All these things can be done by using this AI. So normally, if you think about a factory, so normally factories will be having machineries, equipments, etc. So to maintain those machineries or factories periodically with manpower is actually a huge task. So if you have some kind of an IoT network with ML inbuilt on it, so it will actually parallelly it will check the condition, how the health condition of all these equipments, all these this machinery, so that if any anomaly is detected, it will immediately inform and it will take measure. And like based on the application, you can go and explain how an ordinary IoT application can be done, or it can be extended or enhanced to intelligent IoT applications. So this is the topic, intelligent IoT applications. Next, I would like to discuss about few IoT levels and deployment templates. So as I told, IoT can be deployed in any levels. So based on the application, as I told, we can have different types of deployments. So first we'll see level 1 kind of deployment. So this is our IoT level 1 deployment. If you see here, we have only one node. One node means, as I told, a node will be a smart object. And that node, it is connected with the resource, and we have a controller service here. So it has a single node that performs sensing or actuation, stores data, performs analysis, and hosts the application in the local itself. So even though we have cloud, in IoT level 1, we are using only the local. We are hosting that particular deployment in the local itself. So these systems are suitable for modeling low cost and low complexity solutions where the data involved is not big and the analysis requirements are not computationally intensive. To explain with an example, say simple smart lock. So a lock that you can lock or unlock by using an app which is there in your mobile. So with basic status reporting, all within that particular own system. So we are not actually using any cloud or any other memory. We are using a mobile app which is there deployed in local, and you, by using or operating that particular mobile app, you are actually opening the lock and closing the lock. So that is one smart application which can be done. This is actually the basic implementation of IoT. So simplest way of implementing an IoT network. And there are so many other examples also. For example, temperature monitoring and displaying it in the in a display. So it will be having a sensor to actually monitor the temperature, and automatically it will display the temperature value. So that is actually a simple kind of implementation without much complex integration of cloud or anything. So this is actually IoT level 1. So next, IoT level 2, if you see here also we are using only single node. The thing is, we have integrated cloud here. So it will be complex than level 1, but not that much complex, because here also we are dealing with light data. So data is stored in the cloud, and the application is usually cloud based. So you're actually using cloud for storing the data. Clear? Only for storing the data. So it is used where the solutions involve a big. However, the primary analysis requirement is not that much computationally intensive, and analysis will be done locally, but only the storing purpose will be using the cloud. For example, in smart irrigation system, where the moisture level of the soil will be sensed by a sensor, that will be an unit. So once that level is below a critical level, automatically what we need is we need to water it. So that can be done then and there itself. So automatically it will open the valve and water will be sprayed. So if you need, that data will be stored in the cloud. So that is for future, actually for future use. So, but the action will be done locally. So no need to wait till the cloud sends a message that you have to water. So actually the watering will be done then and there itself when it detects that the moisture level is very less. So that is one smart application which can be deployed by using this level 2 kind of an deployment. So I hope this is also clear. So here also, if you see, we are using only single node. And third level, that is IoT level 3. Here, the cloud is used for not only for storing, but also for analysis also. So the analysis requirements are also done in cloud. So this is little bit computationally intensive than the previous one. So to explain with an example, a smart city traffic management, where sensors and cameras actually deployed, they feed traffic data to the cloud. So it will be in cloud that will be analyzed whether they are misusing, very untoward incident happens or any traffic violation happens. It will be analyzed in the cloud, and automatically the measures will be taken. And also it can be used to reduce congestion. All these things can be done in the cloud. It is not locally done, but it will be analyzed in the cloud, and the instructions will be coming from the cloud to the central manager. Okay, if you see here, we have a controller service, so which is connected to the cloud. So the instructions will be coming from the cloud to actually actuate or to do action, some kind of action. When compared to level 2, level 3 differs in that in level 2, actuation will be done locally, whereas in level 3, for to do action, the instruction should come from cloud. So that is the difference between level 2 and level 3. And next, if we go for level 4, this is a bit more complex. As we move along, the complexity becomes like increasing. Complexity increases. So here we are dealing with more than one node. So it is not a single node system. Here we are actually having multiple nodes, and we have two important things here. One is the observer node. So if you see here, one observer node is there. So the main purpose of this observer node is to get data from the cloud. Okay, it will coordinate data with the cloud, and it will be actually analyzed, and it will be used in the local. Okay, so here also we have an observer. So this observer node actually is connected to cloud. So the main purpose is the observer node, which can subscribe to and receive information which is collected in the cloud from these particular IoT devices. So where these actually IoT level 4 is used where multiple nodes are required. So till now we have seen systems with only single node, but from now onwards we'll be seeing the applications wherein we need multiple nodes, and data involved here will be very big, and the analysis requirements are also computationally intensive. So for example, we have industrial asset monitoring system. So as I told, in industry we'll be having different machineries. So vibration, temperature, pressure, all these sensors will be actually deployed or connected with all this machinery, and local analysis to detect anomalies will be done. That, as I told in level 2, this is a bit more complex. So here it will send critical alerts and those summarized data to the cloud. So here predictive maintenance is also possible. So in previous case, when I explained this particular example, predictive maintenance was not there. So if you need a predictive maintenance, so it will predict that this machinery has to be maintained, or some maintenance has to happen in a particular machine or particular equipment. So that is only possible if you have a cloud, and also the data is analyzed in the cloud, and some kind of AI algorithm is run in the cloud so that it will predict that maintenance is needed. So IoT level 4 is also most commonly used deployment template. So this is one application we have. If you think, you can have multiple kinds of applications by using IoT level 4. And also in IoT level 5, here also there are multiple nodes. And one important thing is here we have another node called as coordinator node. So since we have multiple nodes, so this coordinator node collects data from the end nodes and sends to the cloud. Okay, we have a common coordinator here. So that coordinator node will collect the data from all these nodes. Since we have multiple nodes, we need to have some coordinator to collect those data, and he will collect all those data and it will be sent to cloud. So that will be the only difference between level 4 and level 5, the introduction of coordinator node to much more streamline the application. So here, if you go for any examples of environmental monitoring, which we have implemented, I will explain it with a case study. So we have actually multiple stations deployed for monitoring the environmental parameters, and we will be having in central, we will be having a node who will be collecting all this data, and it will actually send to cloud. So level 5 is also most commonly used deployment. And the last deployment is what is called as IoT level 6. So here, if you see the difference, only the difference is we have a centralized controller. So here the centralized controller is aware of the status of all end nodes and sends control commands to the nodes. So here in between this coordinator node and the cloud, we will be having a centralized controller. So here the centralized controller will do the role of coordinator node as well as the role of observer node also. So observer node also will be aligned in with centralized node. So the centralized controller, he will control cloud as well as the end node. So he will be actually acting as a bridge. So this is also most commonly used template wherein we are thinking about a large deployment of IoT network like a smart city infrastructure where multiple kinds of architecture will be there. So for example, for street light, we will be having a one architecture. For water distribution, another architecture. Okay, so likewise for traffic management, we will be having another architecture. So like if you have multiple architectures involved in a single network, we should go for such network wherein need a centralized controller. So this IoT level 6 is the most complex system or architecture where it will be used only in such cases wherein if you are in different heterogeneous kinds of deployments. Okay, heterogeneous kinds of deployments in a single IoT network. In those cases, you have to go for IoT level 6. So once again, I will brief all these levels: IoT level 1, 2, 3, 4, 5, 6. So level 1 is the simplest level, wherein we have only one node and we will be doing the processing in the local itself. In level 2, we will be using cloud for storage. Mostly the action will be done in the local itself. In level 3, both storage and actions are performed only after getting the instruction from cloud. And level 4, here we have multiple nodes and we will be using cloud for analysis and for also storage and to give instructions to the nodes. And in level 5, it is a bit more complex than level 4. Here we'll be having a coordinator node. Since we have multiple nodes, so the coordinator node will coordinate and it will send data to the cloud. And level 6 is the last level, wherein if heterogeneous networks are in a single IoT network, we have to go for IoT level 6. So this is regarding different deployment levels of IoT. So if you see the research perspective, so recent research highlights the need for integrating data science and IoT to achieve intelligent decision support. So addressing challenges such as security, privacy, and adaptability in IoT ecosystem. So we have to integrate. So all these data, so which are collected by using sensors. So we need to analyze all these data. Otherwise, it will be a waste. So once we can find some kind of pattern or some kind of meaningful way of things from this data, you can use and you can act on this data. So for getting data, you need to deploy IoT. So that's why IoT is used for getting the data, and AI is used for analyzing an action, for performing the action. So that's why the convergence comes AI IoT. So AI IoT is predicted to transform numerous domains, including healthcare, smart cities, industrial automation. So many fields you can integrate AI and IoT, and you can bring remarkable changes. Okay, so simply using IoT, you can perform an action, but if you are integrating AI, so it can do wonderful things. So some of the examples I will explain in coming slides. So ultimately, my aim is to cover both this, how AI and IoT is integrated. So again, I will brief machine learning also. So I hope all of you may be knowing machine learning. So machine learning is a subset of AI that enables systems to learn patterns from data and make predictions or decisions without explicit programming. So some kind of patterns will be recognized or classified based on the data that we are actually imparting to the machine. So that machine learning is actually a subset of AI. So and also in IoT, ML transforms raw sensor data into actionable insights. So as I already discussed, if you are integrating IoT with ML means, as I told, IoT can generate data and ML can actually transform those data into some actionable insights. So some of the applications, air quality prediction, flood level water forecasting, these two things I will be explaining: weather prediction, disease diagnosis, image and speech recognition, smart traffic control, customer segmentation. So all these things can be implemented. So we can implement both this IoT and ML or AI IoT in all these fields. Again, if you classify ML, these are the broad classification: supervised learning, unsupervised learning, reinforcement learning. In between, we have some unsupervised or semi-supervised learning. So all these things are the different classificational techniques of ML. So in supervised learning, you will be using labeled data. So if, for example, for air quality prediction, you will be using some kind of gases or the parameters which are actually degrade the air quality. So they are actually labeled. So that's why they are called supervised learning. So in unsupervised learning, so we are not dealing with unlabeled data. We are not dealing with the labeled data, but the data will be different. So we need to have some kind of clustering or some kind of mechanism to find out the behavior. So that we call as unsupervised learning. So in reinforcement learning, actually the machine will learn with the trial and error method. So for example, driverless car, all these are examples for reinforcement learning, and all these fields, so like as agentic AI and all are coming. So they are all actually booming the need for reinforcement learning in machine learning applications. So this is the broad classification of ML. And this will be the workflow of ML. So as I told, data collection will be the first thing. So that can be in real time, that can be by using IoT nodes. If you are going for a real time application with ML, so data can be collected with sensors and it will be from an IoT node, and that will be passed to next stage. The first stage of this ML will be the pre-processing. So in pre-processing, actually we'll be doing the cleaning. So actually the data which is received from an IoT node will be inconsistent, or we have to fix error, or sometimes there will be missing of data. So all these things can we have to do, or we have to perform all these things before we feed that to our ML algorithm. So that is our first stage of cleaning. And then normalization is another method where actually, if you see, it is another important pre-processing stage wherein we are actually either we are scaling it up or scaling it down. So that process we call it as normalization in order to generalize the data, so that some dominating features will not be highlighted, or some dominating features which are there in the data will not shoot up. Okay, so that's why we are normalizing the data. And also we have feature extraction, that is barely, so the bare or raw data will be converted to some meaningful data. So these are some of the procedures which are used in data pre-processing. And then once this is done, our data is neat and clean. So we can use those data to train our model. So again, that model we as last slide we have seen, we have different types of model. We can choose any of those model, and we can come with some kind of learning patterns by using the data, so that we have to find which model works fine. That will be actually a trial and error or experimentation process. We have to run all these models. If we need, based on the application, we have to come up with a suitable model for the application. And the next stage is to use the AI algorithms for prediction and analysis, or we can forecast or predict or detect. So all these things can be done by using this model. So again, the accuracy depends upon the model. So this can be done in the next stage. And last stage, we can give alerts or insights, or it will be the output. So what we are going to do with that particular model, or what that machine will actually do. So that will be the output. Input will be the data, output will be an action. Okay, so action in the sense it can be a message, or it can be a signal, or it can be an information passing to users based on the application. So that will be coming out of that particular model. So this is a general workflow. So again, this workflow I will explain with an example. So with the case study. So how this slide is to show how that particular ML or workflow will be followed in any machine learning technique. So again, the IoT and ML. So IoT focus on connecting physical objects to the digital world. So by real-time sensing of physical and environmental parameters, large-scale deployments of interconnected device, reliable data acquisition and communication. So all these things IoT will focus. On the other hand, the machine learning will do its part by learning some patterns or trends by using this data set, making some predictions and informed decisions. And also this is actually a continuous process, whereas continuously it will improve the performance. How long the data is like extended, that long the performance also will be improved. Like bigger the data, more the performance. So we are asking the machine to learn. So we need to give the data. So the data, we have to give a trusted data. We have to give a neat and clean data. Once we give that, the machine will learn and it will predict or it will forecast. So to summarize, IoT will provide data and ML will provide intelligence for applications. So that's how this IoT and ML are blended or linked or synced or whatever you can call it as. So that's why IoT and ML are actually plays very important role in modern day applications. So these are the case studies. So yeah, 640. So, okay, these are the case studies. So I'll be explaining. So first is the air quality monitoring system and second is the flood prediction system. So these are the some of our products developed in our lab. So this is actually the air quality monitoring. So AWS station, which is developed by our lab, and this is level sensor developed by our lab. This is AWS again, and this is actually the AQMS, air quality monitoring system. And this is actually the indoor air quality monitoring system, which is developed. And all these products are developed by our faculty or staffs in our lab. So we'll start with the first case study. First case study is air quality monitoring system. So as I told, we have used IoT and also we have used AI. So first we'll see the IoT part, that is the hardware part. So in the hardware part, we have sensors. We have AQI sensor, we have temperature, pressure, humidity, and we have different gas sensors like NO2, NH3, SO2, CO. So likewise, we have so many gas sensors. Again, all the data will be collected by using these sensors. And we have used ESP as our microcontroller. And also in some of the application, we have used GSM also. And also we have used LoRa. So based on the terrain and based on the place where this particular device is actually deployed, we have used the communication technology, either LoRa, GSM or Wi-Fi. So as I told, sensor will generate data and we have used a microcontroller and we are using the connecting technology and it is connected to the cloud. So this is the hardware part. And next is the AI part. So in AI part, as I told, we have used different sensors like PM 2.5, PM10, CEO, NO2, SO2, NH3, all these sensor values we are actually collecting these collected data is pushed through LoRa to our web app, to our cloud. And in the cloud, we are performing the AI algorithms, or we are using AI algorithms or deep learning algorithms to forecast and also to predict the air quality in coming days. So, and that is visible in our application, web application, which we call as AirAware. So in AirAware app, if you go and see, there will be a real-time visualization of the AQI value in the deployed states. And also there will be forecasted levels and also location aware air quality insights. So that is one of the novelty which we have brought in this particular project, and also health risk alerts. So all these things are some of the systems which we have developed, which is the novelty of this particular project. So this is how we bring in AI into this context. And if you see here, this is the actually this map shows the Karadi Panchayat here. So this is the area, and this is where we are, Adi Shankara Institute of Engineering Technology, and we have deployed one module here and one here. So totally we have deployed 5 IoT modules to predict air quality monitoring. So to predict air quality. So all these deployments are like, for example, deployment in Karadi Gram Panchayat here, we mostly concentrate on CO. So carbon monoxide, because it is hugely involved with the traffic data. And here, this is mostly depending on NH3 and SO2 because an industry is nearby here. So based on the area, what type of sensors you need, you have to use those sensors to predict the air quality. So air quality is predicted by using AQI, as we all know. In order to calculate AQI, you need at least 3 different parameters. So that 3 different parameters you can choose based on your location. For example, in our college, if you are going to predict AQI, traffic has no role to play because traffic is not that much a severe issue in our college. So we can go for other parameters. Okay, so whereas in Grama Panchayat, if you are going with the NH3, there will not be any use because there is no industry involved in this particular area. So the mostly in the area is covered with the traffic. So we have to go with carbon monoxide or carbon dioxide or even any other poisonous gases to calculate the AQI. So all these places we have calculated AQI. And one more technology we have developed, I will explain in the coming slides. So this is the equipment, air quality monitoring station or system which we have developed. So we have deployed particulate matter sensors like PM 2.5 or PM 10 and gas pollutants like CO, NO2, SO2, NH3 and O3 based on the area. Okay, based on the area, and also some meteorological parameters like temperature, humidity, pressure, which will be common in all the hardware modules. So again, if you see how to predict this AQI, we have used the technology. So again, how to predict, so how to forecast, how to use this AI in AQMS. So AQMS, as I told, air quality monitoring station. So this environmental data actually exhibits temporal dependency. So temporal dependency is basically depending on past data or to analyzing the past data. So last year or last month, how was the air quality in this particular area? Those data we call as temporal data. And also there are some seasonal patterns, like if it is a festive season like Deepavali and all, obviously the atmosphere will be surrounded with crackers and also that will actually ruin the atmosphere, the air quality. So that is also considered, and also non-linear behavior. So if something happens in an emergency case, so that also considered. So by considering all these three parameters like past data, what happens in seasonal, and also some non-linear behavior in the sense some kind of urgency situation, some kind of disaster happens suddenly without any prior indication. Like for example, say fire accident happens, so that automatically emits poisonous gases. So those kind of situations also we have used for our model. We have trained with those data also. So again, in machine learning, by using machine learning, we can find out a pattern. We can actually forecast the air quality, and also we can make decision proactively without waiting to get instruction. It will act then and there itself. So that ML actually provides the insights to act. So that is the air quality is alarming. So we have to do something. And also, as I told, personalized health risk is also involved here. So a person who knows his health condition, and this AI model will tell him that since your health condition is very bad, in coming days, the air quality will be very poor. So you have to take precautions. So all this decision-making process will happen in this particular model. So, so we have implemented, if you go with the ML, we have implemented 4 types of ML DL algorithms like LSTM, BiLSTM, GRU, and BiGRU. So these are the pollutants which we have used: PM 2.5, PM 10, SO2, NO2, CO, NH3, and O3. So we have calculated AQI, air quality index, by using Central Pollution Control Board formula. So the Central Pollution Control Board actually has a formula in order to predict an AQI. At least you need to use at least any of these 3 parameters, either PM 2.5, NO2, CO, or NO2, CO, NH3, or like any of 3 parameters can be used to calculate the AQI. So there is a complex formula for that. So for that, we need at least 3 input from these particular things. Apart from these things, any other that can also be added, but 3 different parameters are needed. So we have actually checked with our Kerala State Pollution Control Board also. So our module, which we have developed, we have kept it in the same area where the KSPCB board is also deployed, and we have cross-checked the values. So what our module is actually displaying, and also what the Kerala State Pollution Control Board is displaying. So almost the values are similar. And also, as I told, in coming to the models which we have developed, we have implemented all these 4 models, and these are the evaluation parameters for our trained data. So if you see MAE, MSC, that is mean absolute error, and MSC, RMSC. So LSTM model, GRU model, and also by GRU model and by LSTM model. So we have selected GRU. So it is not that GRU will be the best model for every application or all the application. So in this particular case, in this particular application or in this particular experimentation, we feel that GRU is actually computationally let's say lower computational complexity, and the accuracy of prediction is more, and the training is faster, and deployment and maintenance is easier. So we have come up with GRU. So GRU is the model or deep learning model which we have used in our application. So these are the comparison with the other models. So we have chosen GRU as our perfect model. And these are some of the results of GRU, LSTM, and the other two algorithms for a single case like SO2 for forecasting SO2. So SO2, so that blue line indicates actually the forecasted model. That red line indicates that original value which has happened. Okay, so this is the results. And as I told, one of the novelty in this particular project is spatial interpolation. So in spatial interpolation, I will explain with that map. So here, if you see, if you take this particular area, we have stations deployed in 5 different locations, 1, 2, 3, 4, and 5. So normally what happens is, so if you are here, if you are, suppose imagine you are here in this particular place, if you check the air quality of this particular area, normally what happens is the nearest or the station which is near to this place, which will be the Adi Shankara Institute. So this value will be shown. Like you are here and nearby you have an industry here, but still if you check air quality here, the air quality will be very good because that will be the air quality data from this particular institute or deployed it with this particular module or whatever the hardware which is deployed here. Okay, so again for here also, so this is a common issue or common problem which is there in our country. So and again practically placing these hardwares in all the location is impossible. So again, the cost wise, complex wise, algorithmic wise, it is very huge task. Like we cannot like implement or we cannot deploy these hardware modules in each and every place where you go. So the only solution here is to go for a technique called as spatial interpolation technique. So this is the technique which makes, or we have different types of spatial interpolation technique like kriging model, empirical Bayesian kriging, inverse distance weighing. So we have so many types of like interpolating techniques. So what done in this particular by using this particular technique is we are actually interpolating the air quality data from that particular space where that person is standing with either by using all these deployed sensors or by using different sources which is surrounded. So all these things are done mathematically, and we have the results which will be like which will tell that particular person the actual or almost similar or a true kind of air quality at that particular place. So again, that is actually measured, and also it is coming up that the kriging model that we have developed, we have used all these models, and kriging model is showing the best result. So like how we tested means actually we took a mobile air quality monitoring station and we took data from that particular unlocated station, and we actually interpolated by using this technique also. So when you compare, the kriging model is actually showing the comparable results with the actual that station value. So this is one technique which this is one of the novelty in this particular project, that is spatial interpolation. So this is I'm ending the case study 1. So this is in case study 1. I will brief here. So what we have done is we have deployed 5 different hardwares. So each and every hardware is actually an IoT hardware which has different sensors deployed, and the type of sensors depends on the area. Okay, and also what it is surrounded. So different sensors deployed in an IoT hardware, and we have deployed it in 5 different locations, and we have used deep learning algorithms for the forecasting and also for prediction of air quality. So forecasting is based on the past data, and prediction involves the current data also. Okay, so that is the difference or similarity what we are calling forecasting and prediction. So that is done here. So this is our case study 1, and in case study 2, so that is case study 2 is actually space flood water or flood prediction. Okay, so again, if some of you might be knowing, our college is in a place called as Kaladi, and near to Kaladi we have a river flowing called as Periyar River. So this Periyar River usually floods, so especially during monsoon season. So due to the rise in water level, the surrounded area of this particular river is actually flooded. So we thought of coming up with an intelligent IoT solution to give an early alert to the people who are located nearby those locations, so that they can shift or relocate from that particular place. So the problem with this thing is, if you simply tell that the flood will happen tomorrow, or flood will happen day after tomorrow, or the water level will rise, people will not move, or they are not willing to move from their home place. So we have to give them a trusted information. So trusted information, for getting the trusted information, we have incorporated explainable AI here. So in this particular application, we have used explainable AI to impart the trusted information which is needed to be like displayed, or to be like given to those people who are living in that particular place, so that they will be convinced and they are ready to move from that particular place. So the input, if you see, we have taken different types of input in order to get that particular project done. We have used wind direction, wind speed, temperature, pressure, humidity, water level, and again dam water level, and also rainfall intensity. So there are so many parameters which are influencing the water level. So again, we have a dam, nearby dam we call as Bodhatangattu Dam is there, which is around 40 kilometers from the Kaladi. So again, the catchment area of that particular dam is again around 25 square kilometer. So the thing is, we have deployed our automatic weather station, so which is the weather station, and we have deployed in the catchment area of that particular dam, and we are getting the rainfall data. So that is actually a major contributor to this particular water level. So again, by using AWS automatic weather stations, we will be getting the rainfall intensity, and also we have placed a level sensor in the Kaladi River to get the level of water. So water level, to know the water level, and we have used LoRa gateway or LoRa connectivity to integrate all this data and to send to cloud. In cloud, we'll be performing our deep learning algorithm, and the flood will be forecasted, and that is available in the web page and also in the app, the same app which that is AirAware app. So this is the basic idea, and this is the hardware. In hardware, as I told, in sensor, we go for rain gauge to predict the rainfall intensity, wind direction, wind speed, temperature, pressure, humidity. All these sensors are actually in that particular module. And we have used again a microcontroller, and we have used LoRa, and sometimes we have used GSM. As in interior places, LoRa is not practical, so we have gone for GSM, so or 3G SIMs, and then from there we have pushed the data to cloud. So this is the equipment which we have developed, AWS automatic weather station. So again, this is the unit which will measure the rainfall, and this is the unit which will measure the wind speed. So again, pressure, temperature, all these sensors are placed in this particular module. So all these things are developed in our lab, and these modules are also fabricated in our lab. So this uses actually tip-in bucket technique to calculate the rainfall intensity. So this is the hardware which we have deployed. We call it as AWS V1 and V2. V1 is the version 1 and V2 is the version 2. And this is our application. So web application, which is AirAware. As I told, this is the one app wherein you can see all these data displayed. So predicting the water level of Periyar River 6 hours ahead using ML is our challenge. So we are actually predicting the river water level 6 hours. So we are actually predicting the water level after 6 hours or hour by hour up to 6 hours. So that is actually an input and a reliable input for the people who are living nearby, because the major source of flood is the rise in river water level. So if you know what will be the level of the river after 6 hours, you can take precautions or you can take necessary actions. So the problem nowadays which the people are facing is they are not knowing whether the water level rises or whether the water level will be decreased or it will be like gone down, because they are not having any knowledge about what is happening in the catchment area or what is happening in the area wherein the source of this river, the water is coming, that is from the Budakuttangattu Dam. So during a heavy monsoon, the whole shutters will be open. So that the discharge of water will be huge, and people, as we all know, we cannot predict the rain also, and sometimes alerts are given, but still we cannot know like what is happening in that particular catchment area. For in order to solve this problem, we have come up with intelligent solutions of installation of AWS, and we have collected all these parameters and we have gone with a model, an LSTM model. So as I told, data sources are dam operations, like dam discharge value, rainfall data, opening and closing of shutters. So all these are one of the inputs. And the river levels, river levels, we have Neelishwaram is one of the place before Kaladi. So before Kaladi, we have an Neelishwaram where Central Water Commission, they are displaying the data. So that data is also taken into account. And also we have placed our own device which will measure the river water level. So by taking all these inputs, we have fed that to an LSTM model, which will actually forecast the flood. So this is the thing. So data ingestion, we have already discussed. We have multiple kind of data like rainfall and water discharge data, level data, and also the data from the catchment area. So all these data we are actually passed through pre-processing stage, where we have used our normalization and also our cleaning process. And after that, we have gone through feature engineering or feature extraction phase. So after all this process, we have made the data ready. So in that data, we have used around 70% of data is used for training and 15% for validation and 15% for testing. So and we have introduced an optimization technique also. So sometimes overfitting of data will happen. So that we have to stop. Sometimes the machine will learn or saturated and it will learn. So that kind of overfitting also we have addressed. And this is the number of neurons 128, 64, 32. And we have used Adam optimizer with the learning rate of 0.001. And these are the values. Epochs is 100, and also around 50,000 data. The size of data size is 55,000 with the batch size of 32. So these are the some of the configuration of our LSTM based flood forecasting system. And these are the results. So if you see here the blue line and green line, so the green line is actually the forecasted value, and the blue line is actually the actual water level. So there are some minute difference, but they are in millimeters, so it will not affect much. And these are the values which are displayed in our website, like 5.06, 5.43. All these are forecasted values. So some are in orange because it is crossing it is giving that orange alert because it is crossing the target level, and after this it will give the red alert. So at that point of time, people have to evacuate from that particular place because it is danger, it is going to flood. So because of this particular river. So this is taken in one of the days during the monsoon. So this is actually like if you see here, the current water level is 4.89. So next hour it is predicted as 5.06 meters. So this is the prediction which we have introduced by using this particular algorithm model and through this project. So this is our actually result, one of our result. And as I told, we have used an explainable AI solution in this particular thing simply because in order to convince people that the information which is provided by the system is actually a trusted information. And so we have used an algorithm called as line. So this actually helps us in giving or distributed kind of value. We have also tried with shape, but line actually produces a little bit more reliable and actionable data. So we went with the line model. And these are the websites which we have referred. So as I told, we have almost we have taken all the data in this particular which are available in the websites. Even though they are available, sometimes those data are actually past data. So we have taken data from 2015 to 2025. So around 10 years data of rainfall and also regarding air quality also. So I will show you the website. So this is our website. So this is our air aware. So this is the one place where you can
Sir,
see
your screen is not visible. I think
not
you
visible.
have shared
Okay,
only this presentation.
okay, ma'am, I will share
There.
that.
Okay.
One minute, ma'am. Is it visible, ma'am? Ma'am, is it visible now?
No, sir.
I'm in
No,
mode.
sir.
Actually, I was responding. Sir, you have to close the. Yes. Again, you have to share your
Okay.
entire window.
Yeah. Is it okay now?
Yes, coming up.
Yes, sir.
Yes.
Yes, sir.
Okay. So this is the website which
Now
I
it's
was
visible.
referring. AirAware. So if you see here, so it is giving the values of air quality. This is one of our station, which is our campus station, which is showing it is as satisfactory. You can go for live AQI. So these values are given here, current readings. So again, forecasted values are also available here. So, and then coming to home, so we have water or weather station. Again, we have two stations here. So it is not visible here. We have two stations. Yeah. Yeah. These are the two stations, weather stations, which currently functional, and two stations we are planning in the catchment area of Budatangettu. One is in Kuttambuda and the other is in the Ayambuda. Okay, so yes, and then we have so many informations mentioned in our website also. We can go through that information. Okay, okay, this is what I intended to present. So if you have any query, I'm ready to answer. So once again, I will share the PPT. If you have any query, please you can ask here. And this is the team.
The participant.
You can email me also. So this is my details. So if you have any query, I'm ready to answer. I'm free to answer.
Dear participants, if you have any queries, you can ask them to sir right now. We have some time before the next session begins.
Sir, I need some details from you.
Yes, ma'am.
So the IoT product, basically, the the performance and the efficiency of the IoT product basically depends on the quality of the sensors that we use.
That's correct.
So can you share some indigenous affordable sensors where from we can get it?
One thing is all these sensors are imported from like foreign countries only. But there are some sensors which are indigenously developed by CMET and also from CDAC and all.
Okay.
But again, if you compare those values with those sensors which are available in the market, it will be different because each and every sensor is using different technology for getting the data. So some in the case of air quality monitoring, some sensors they are using some chemical reaction to find the value of the that particular pollutant. In something, it will be using some kind of photo resistance technology, and like we're using light and all. In sometimes it may be using simple like for example, in case of PM sensors, it will be using the to measure the size of that particular sensor. So likewise, the technology is different for different sensors, and you cannot compare two sensors because two sensors may be using different technology to find the same pollutant value. And we have used many of the sensors which we have used are from CMET. So they have directly given us the sensors. And some of the sensors which we have procured from the market are from an agency called as Prana Air. So they are actually one of the company or one of those companies which are involved in air quality monitoring and deploying air quality monitoring stations. So since we are using those values for research purpose, they have like given us those sensors. And also there are so many sensors which are already available in the market. So you can buy those, but the difference between an industrial grade sensor and a normally sensor will be the duration and also how long it will survive, because we are deploying it in the outdoor conditions. So in outdoor condition, so it will all these environmental parameters will affect all these climatic changes like sunlight, even heavy rain. All these things will affect the value of the sensors. So the duration depends upon the quality of the sensor. Again, quality will depend upon the cost. So how much you are ready to like pay for getting those sensors. So to get really good sensor, it will be around lakh rupees. But again, in 500 rupees, you will be getting sensor. So the difference will be how long it will survive and then how accurately the data is like fetched. So again, to add to this particular thing, so we need to calibrate all these sensors. So it is not that once you deploy the sensor, lifelong you will get the data. So the thing is, you have to calibrate all these sensors regularly. So with for example, we used to calibrate every 2 weeks because since we are trusting on those sensors, we need to calibrate all those deployed sensors by using some kind of a calibration mechanism. And also we have another application of our machine learning, that ML, is to actually detect the anomaly. So sometimes all these sensors may be faulty and they will be giving us the wrong data. So we need to identify whether the data received is correct or not. So we have kept a target level, and that machine learning algorithm will check whether the received data is in between that level. If it is not, automatically a red signal will be given that some kind of anomaly is there in that particular area. So but that particular hardware. So again, we have kept a check in the sensor value also. So that is one thing. And again, you asked regarding the sensor. So we have gone for a CMET sensor and also Prana Air sensors.
Okay, sir. Sir, I heard now some exposure to IEEE sensors. Is there any such chapter? And
yeah, IEEE sensor chapters is there, but they are not involved in manufacturing sensors or not. But the only things they are, as I told, the research in sensor area is actually a huge area wherein people are involved in developing those materials which can be used to like fabricate a sensor. So most of the works are published in IEEE sensor journals. That is actually material science works. And again, those works need like those kind of materials which are readily available. So in India, we are actually shortage of all these materials which are actually used for fabricating the sensors. So nowadays, graphene is used as one of the alternate solution for fabrication of sensors. And sometimes we were using silicon wafers as the ideal material. And like new materials are coming. So ultimately, all these works are published in IEEE Sensor Journal, and they don't have any like company or such kind of thing wherein they will provide sensors and all. Works are available in those journals.
Okay. So that because of the cost.
Yes, ma'am. Cost we can like if you are informing or if you are conveying that the values or the sensors are used for research, then they will definitely reduce the cost. As I told Prana here, so we inform them that all these sensors are used for deploying for a project which is funded by government. So they automatically like gave us the concession, and they trusted us,
Get the
and we are in touch
subsidy.
with them.
Okay.
So we are in touch with them. So actually they are also monitoring our work, because ultimately we should not harm their work, because they are actually a solution provider in this area. So actually we are in touch with them. They are also like in touch with us, like what we are doing. They are also closely monitoring. So it's actually basically sharing the data, sharing the information, sharing the knowledge, what we have, and getting the knowledge from their expertise also. So some people will help like giving subsidy or concession, but again for that kind of project, sometimes you have to go with marketly readily available sensors which are readily available in the market. And so again, you have to experiment with different sensors, and we have to come up with some kind of experimentation data, because otherwise you cannot say that deploying one sensor value and claiming it as the accurate value will not be a correct way of doing that. We have to try with different sensors, and also pollution control board, they have certain kind of sensors deployed, that is actually government agency. So their mechanism is different, but again, the value will be more or less similar. So for example, AQI prediction value will be more or less similar. Say sometimes 70, ours may be 80 or 81. So those kind of things are there. Again, you can try those things.
Sir. Sir, since you have the practical experience of doing this, I would still like to know. So you have the IoT device, and you have integrated with the web application. What are the practical challenges that you have encountered during this process? Then how you tackled them?
The practical knowledge is the connectivity, ma'am. First, what we did is we actually used our Wi-Fi, readily available Wi-Fi. So as you all know, the Wi-Fi is actually blocked using the firewall. So automatically, any external network we cannot connect with that firewall. So that was one big practical problem which we faced, breaking this firewall. That is actually our personal problem. So in order to solve that firewall issue, what we did is we actually formed our own network, and we are using our own network to connect the cloud, to integrate the cloud with the hardware which is developed by us. And also we are using LoRa. So LoRa, another important problem is LoRa. Actually, in theoretical perspective, LoRa is actually claiming that 4 to 5 kilometers range. But in our practical cases, maximum of 800 to 900 meter is what we got. So that network, LoRa network, actually provides connectivity to 800 meters maximum. So the hardware which is placed in the visibility of that 800 meter will be connected to LoRa, and that data we can directly connect to cloud by using the chip in value. So that is one difficulty. The other difficulty which we faced was so connecting the cloud and analyzing the cloud. So, and again, if you see cloud, the we are not like sometimes all these we are actually pumping our every minute data. So in every minute one data will be actually sent by these modules. So the number of data is actually huge. So later, by analyzing all these data, some false data is also coming, from noise data is also coming. So all these things are actually adding to the data value. So the bill which is coming every month is actually different. Each and every month, the cloud bill which we are paying is different. So suddenly, 1 month we got 7,000 rupees. All the other months we had 3 to 4,000. So when we checked it, some raw data is also coming, some kind of noise data is also coming, some equipment was fault. So again, even though it is false, it is sending data. So this made us to keep a check on the data which is pushed from that particular hardware. So these things were some of the practical problems which we faced. And again, problems will be there when you implement such systems in practical scenario. But the thing is, you need to identify what was the exact problem and to come up with a solution. And again, to come up with a solution will not be easy. So we have to trial and error. So you have to do the trial and error method. Which one suits best? We have to adopt that particular strategy.
Okay, thank you, sir. I'm trying to learn from you. Sir, you had a subscription. No, you have taken the subscription of cloud. When
Yes,
we
ma'am.
take the subscription, what are things that we have to look into it?
To
No.
get the cloud subscription, no, like only we have to register in that, and we can opt for prepaid and postpaid. So we have opt for postpaid kind of thing, and the bill will come, and we are paying for what data we have consumed, what data we have used, or what space we have used. So again, different kinds of platforms are there. So we have used AWS, and
Okay. So you use cloud only for storage.
Analysis also done, ma'am. Our
Okay.
machine learning algorithms are running in the cloud itself.
So you are not taking those services.
Yeah, we have taken those
You are doing
services
that.
also.
Okay.
Cloud storage and also for storage. Again, for storage, if you means we have a physical server also. But again, as you told, there are so many practical difficulties in syncing our physical server with the IoT hardware. So so that API is not getting connected. So that physical server was actually waste. So we thought, instead of physical server, why can't we go with the cloud? So cloud was a bit more easier than the connecting with the physical server. So we thought we'll store the data in cloud itself.
Okay. Thank you, sir. Thank you. Thank you
Okay,
for generously sharing all your experiences, providing
all
the
these
details.
things. Actually, it's not my own work. As I told, there is a team behind this. All these people, I'll show you. These people are doing it. They are actually sharing with me. They are making me understand how they have done, how we are doing. We will be discussing all these things, and we will be coming up with solutions. So this is the team behind all this work. So I appreciate
Obviously,
their
it's a
hard work
teamwork.
and sincerity. Yes, ma'am. Okay.
Thank you, sir. Thank you, sir.
Okay, ma'am. Thank you.
Thank you very much, sir. The session was
Thank you.
very beneficial to all the participants. Dear participants, we'll take a 10 minutes break and we'll meet again at 7:30. Thank you.